So for this question, the first thing you want to do is you want to realize that work dissipated from friction is going to be equal to force friction times distance. However, since distance is changing, it would be equal to force friction, or since the force friction is changing, it would be equal to force friction dx. Next, what you want to figure out is the amount of the chain, like of the mass of the floor, because this is going to be equal to the integral of mg dx gu mu. So to figure out the mass of the chain, you can do m is equal to mass of the chain times the amount of the chain on the floor times the length of the total length of the chain. And this basically gives you the percentage of the chain on the floor times the mass. So then what you're going to do next is you're just going to plug in this for the mass, and you're going to get mu mass of the chain x0 minus x over L0, or L chain, times g dx. And then you would just solve this integral by just taking the integral of it. So since mu is a constant, we can just take that out to the front like this, mu. And since the mass of the chain is also a constant, we can take that out to the front. And since gravity is also constant, we can take that out to the front. So we're left with, and since the L length of the chain is also a constant, you can take that out to the front too. And then that just leaves you with integrating x0 minus x. And x0 is just a constant, so since x0 is just a constant, it would just be multiplied by x. Like that. And that would give you, when you plug that in, when you plug in 0 for x, they would cancel out, so you would just have to plug in x0. And when you would plug in x0, you would get mu k ek m chain gravity x squared, x0 squared over 2 LC.